On May 3, 2019, in Peoria, Illinois, a team of Penn Staters made history. They became the first ever to build a fully enclosed 3D printed habitat at architectural scale without any support structure beneath. It was the final round of NASA's 3D Printed Habitat Challenge competition to design and build a structure suitable for Mars. The achievement, a culmination of years of research and design from an interdisciplinary team led by Penn State faculty.
The idea here was not to just design a common building, but to innovate the construction process and the architecture. So I got interested in digital fabrication, and particularly on the 3D printing of concrete. We made what we call functionally graded materials. The idea is that you replace part of the aggregates in the concrete with a lightweight material that has good insulation properties, for instance, cork.
I had a vision to transition seamlessly between concrete and glass without the use of any mechanical frame or bonding agents. That would make such a difference in architecture if you were able to do something like that.
We developed what we call Marscrete, which is a kind of concrete that's made of materials that can be found on Mars.
Constructing a habitat on Mars had new challenges for us. When you go to Mars, you're dealing with a lot of loads that we designed the structure, we designed the material, we designed the reinforcement to resist those loads so that we provide a safe structure.
My role as part of this team was to really think about the systems aspects. How do we go from the micro scale to the macro scale? That's a big systems challenge.
Another revolutionary approach was to design the building and the process simultaneously using artificial intelligence and building information modeling. This enabled the team to produce a building that not only pushed the limits, but in fact could be built. There were 8 levels in the competition that involved nearly 80 teams from around the world. Only 2 reached the final round.
We only got our robotic arm about 2 weeks before we went to the competition, so we were learning things in real time.
Both teams set out to build their subscale structure in just 3 days.
We had never actually tested printing the entire thing.
By day 3, it was down to the wire.
The last bit was the most difficult one. It was going very slowly. It seems that it lasts forever.
The team finished with just 11 minutes remaining on the clock.
But seeing everything being printed all together at the same time was like seeing a dream coming true.
We're very proud. We've achieved this goal of creating the very first building that is completely 3D printed, including the roof.
This is something that hasn't really been achieved on this scale before.
You look at the challenge that was set before us, the team that we brought together, and then the competition venue, it was really quite amazing.
I'm really proud of my team and how we were able to achieve this.
Everybody was needed. Every person on there was vital. If we would have missed one of those skill sets, we couldn't have done it. Being a part of that and being a part of the success of that was very rewarding. Once-in-a-lifetime experience, really.
We can really push the limits. What we think is the limit today becomes just the innovation of tomorrow, and then just the everyday use material the day after.
I think that someday we would be able to build on Mars and eventually live on Mars, and looking forward to that day.
Nothing is impossible. We can do everything in a team as long as we are dedicated and responsible for whatever we have.
We have used the competition to accelerate our research. This has enabled us to do our research much more quickly and gain more visibility.
Our mission is to use all these innovations and the experience that we have gained to make an impact, to make a difference in the real construction.
Penn State allows us to unite forces between various disciplines and bring ideas together.